Hi, college algebra students. I'm Heather Peters. I'm your instructor for college algebra. And I just wanted to walk through the next applied learning activity with you so that you have kind of an idea of how to get started. So I'm going to walk you through that on my screen. I'm just going to get this started here. Close this out first. Okay, so you should be able to see my screen now. If you go to the Applied Learning Activity 4, that's the one about slope for this week, and click on it, it's going to take you to an activity about slope. So just a reminder, there's a little introduction here and there's a little reminder of the slope formula. So the slope is the change in y over the change in x. So you can find that if you have 2 points by taking the y2 minus the y1 over the x2 minus the x1. So in the primer, there's a little example. It's taking a graph and you're going to find 2 points on the graph and find the slope between them for this activity. So this example is about the atmospheric carbon dioxide in Hawaii. And the points we're choosing is between the years 1960 and 2010. So you may have to estimate on some of these graphs where it's at. So 1960 looks to be about 315. So we'll use the point 1960, 315. And then we can also pick 2010. So a good way to go about these problems is to just pick the first and the last point. That will help you find the average rate of change. So 2010 appears to be at about 390. You may have to estimate if it's off the graph. So maybe you would have wanted to use 2000 instead, but this is just going to be an estimate. So I picked my 2 points and then I'm going to find the slope between those 2 points. So the y value for 1960 was 390. 315. The y value for 2010 was 390. So if I use this as my second point and this as my first point, I'll do the second y minus the first y over the second x minus the first x. So it'll be 390 minus 315 over 2010 minus 1960. And that gives you 1.5 ppm per year. So this is just kind of an example of how to do it. So what you're going to do on the assignment is you are going to find a graph or chart similar to this graph from above, where the independent variable is plotted against the dependent variable. So you can just Google search different graphs, maybe pick something that is interesting to you. If your hobby is video games, you can look and see if there's any graph out there related to video game usage or basically anything you want to look at. So for an example, I have a graph here. Scrolling. Okay, so regarding travel, I love to travel, and so I looked up some information about travel and found this graph. And this is the global air travel increase between 1974 and 2014. So what the activity is going to ask you to do is to take this graph, and please insert the graph in here so I can see what you're referencing, and describe what each variable represents, and then show the calculations for the slope between the 2 points. So for an example, I'm going to split the screen here so you can see both of them at the same time. Okay, so these variables, so the independent variable is going to be on the x-axis and the dependent variable will be on the y-axis. So my independent variable, if you can see this here, is going to be the time in years, and the dependent variable is going to be the millions of passengers. So when I find the slope, I'm going to pick 2 points. I decided to pick the first and last points. So in 1974, and I'm using the blue graph, the light blue one. In 1974, there were 450 million passengers. So that's one of my points. And then I'm going to go to the end. And in 2014, followed up to the graph, there were about 3,500 passengers. So it may be an estimate. That's okay. It doesn't need to be exact because a lot of the graphs you'll find online won't have the exact points. And then I'm just going to find the slope. So I'm going to do the y2 minus the y1. So 3,500 minus 450 over the x2 minus the x1. So 2014 minus 1974. And that ends up giving me 76.25. Now, we've shown the calculations, which it asked us to. And then it also says, so to show the calculation, and then for part B, explain the meaning of the slope in terms of the units of the variables. So since slope is the change in y over the change in x, your units are going to be the units of y over the units of x. So my y units, if you remember, were millions of passengers. My x units were years. So this is going to be 76.25 million passengers per year. So it's the dependent variable per the independent variable. So what this means, since it's positive, is that it's increasing. So the y in particular is what's increasing. So on this one, you'll see that I said for every year that passes, the number of passengers using global air travel increases by 76.25 million passengers. So that's what I'm looking for on part B. On part C, it says to analyze and talk about the slope for data outside the scope of your graph. Will the slope continue or change in some way? And then offer rationale for your response. So it's kind of like predicting what's going to happen outside of the domain that you have here. So I wrote, I believe the number of passengers flying globally will continue to increase at a similar rate because more people are seeing the value of international travel and there are more options now than before. However, I do think at some point it will level off unless some new technology makes travel significantly cheaper and quicker, in which case it would increase at a faster rate. So you're basically making a prediction for what you think is going to happen after this graph ends. So beyond the graph, what are your predictions? Then for the last question on the first example, it says, consider hypothetically what the slope may do since this is a real world application. Are there any real consequences to be considered if the slope changes or does not change? So if the slope were to continue rising by 76.25 million passengers per year, what would the implications be? What would that mean? So if the slope keeps continuing at this rate, eventually everyone in the world will travel globally. So a lot of times it won't make sense. If it continues to grow, there's no way it could continue to grow because of certain factors or restrictions. So just mention that in part D. So that's the first question. Then the second question is basically doing the same thing, only you're using your own data and creating the graph. So you can gather some data about 2 variables that you think might be related. And I have on here to ask or survey 10 people in your life, but you could also get some information from online. However you want to go about doing that, just make sure you have 10 data points. And then we're going to graph the information as ordered pairs. So choose 2 variables that would give you numerical values. So I wouldn't use something like my name and my shoe size because my name is not a numerical value, but I could use my height and my shoe size because both of those are numerical. So I have some examples listed here that you could take a look at if you'd like. And then you're going to use Microsoft Excel or Desmos, whichever you're more comfortable with, to create a graph. So I'm going to pull up Excel and show you how to do this for those of you who are not familiar with how to create a graph. So my data, I am going to use, so if you interview a couple people, 10 people to be exact, you you're going to get a bunch of different values. So maybe you want to interview people and ask them about their age and then how many hours of sleep they get a night. So maybe you interview someone who's 26 and they get 8 hours. Someone who's 19 and they said they got 6 hours. Someone who was 19 and they said 4 hours. Yikes. Maybe someone who's 21 and they get 7 hours. 30 and they got 8 hours. Okay, so you're going to have 10 data points. I'm just going to do 5 for the example right now. So then if you want to graph this, you can go to data. Or you can do insert actually. Okay, so insert, if you go to insert and then go to charts, we'll just make a scatter plot. So, okay. And then it's going to plot my data here. Now, you'll notice, share the screen with this one so you can see what question it's answering. It says to create a graph and to make sure that your Excel graph has each axis labeled and the graph is titled appropriately, to describe the situation. So mine, for example, was age and number of hours of sleep. So you could say something like number of hours of sleep for various ages. Whatever you want to title. Oh, I should probably change that spelling there. Usually the titles have capital letters and keywords. Okay, and it will create my chart title for me. So you just clicked on this and wrote it in here. Now, if you want to label the X and Y axes, this little plus sign to the right of your graph has some options. So if you do axis titles, that's the X and Y axes, and it will bring something up that says axis title, and then you can type in there what you want your axis title to be. So if I want this to be age, and then I want this axis, you can type that in here. I want this to be the hours of sleep. It will change it in here for me. Okay, so there's my graph. You can cut and paste this in here. You can use the snipping tool. I usually, if you have a computer like mine, I go to the search and start typing in snipping tool, and it brings it up. So then I can create a new snip, and I can just cut and paste that. So Control C, Control V, and it will paste it into my document. Okay, so then the next question B is to find the slope between 2 points. So this is exactly what you did in the last problem. You just pick 2 points. If you want to pick the beginning and the end, that will give you the average rate of change over the entire age range. So you can find the slope here using the same process. And then part C says to explain the meaning of the slope in terms of the units of the variables. So exactly like what we did on the last problem. Mine, since slope is change in y over change in x, it's going to be the units of y over the units of x. So whatever I get for my slope, it's going to be the hours of sleep per age. So maybe it means for every year I get older, I get this many more hours of sleep. And I'm assuming it's going to be a positive slope. But if it was a negative slope, then it would be the hours of sleep are decreasing as I get older. Okay, so that's what you're going to do for C. And then for D, you're going to analyze and talk about the slope for data outside your scope of your graph. So exactly like what you did in the last problem. So since it's a real life situation, do you think the slope is going to continue or change in some way? Why or why not? So if my slope is increasing, I don't think it's just going to keep increasing it, because eventually there's only so many hours of sleep you can get in a day. So if this keeps rising, maybe someone who's 80 is going to get 30 hours of sleep in a day, and that's just not feasible. So you could say, you know, the slope will start to level off maybe around 8 to 9 hours, or it could start to go down as you get older, just whatever you think is going to happen. So there's not a wrong answer to this. It's more of what your prediction is for what your slope's going to do in the future. So that's kind of an example to hopefully help you with this week's learning activity. If you do have any other questions on the learning activity or any of the homework, please, please, please don't hesitate to email me or set up a time to conference. Thank you very much.